What is up, Flutter devs? In the last video, when we were working on porting processing to Flutter, we implemented the core APIs, the most fundamental APIs that allow us to render a processing-like sketch in Flutter. But where we ended, it was really tedious to actually define each of our additional sketches. We had to subclass this thing called sketch. So we had 4 tests, 4 subclasses. That's going to get out of hand very quickly. In today's video, we're going to figure out how we can simplify the definition of a sketch so that when possible, or when it makes sense, we can do so with far less code, less verbosity, or what some people might call ceremony. So let's jump over to the desktop and figure that out. Let's start with where we left off. Here we have a series of tests. These tests were designed to make sure that, okay, we can actually pass in a sketch, the sketch runs, we can paint a background, and that proves the overall approach for now. Here's the problem. Every one of these tests has an instance of a sketch. At the bottom of this file, all of this code here is required to implement those tests, implement sketches for each of those tests. Each one of these is essentially one line of painting code, one line of an actual processing sketch, and yet look at all of these lines of code that we waste. Similar to what we did in the last video, to solve this problem, I'm going to start with what I wish I could do and then work backwards. In other words, start with the goal and then figure out how to get there from the implementation of the code from the beginning. Here's what I would like to do. Right here, where I want to paint a background, this is what I would rather define. I would rather say, and again, this is just off the top of my head, maybe we're going to massage this API, maybe not, we'll see. I think that I would like to be able to say something like sketch draw s.background, and let me go grab that color. And then just to be clear what I'm talking about here, if we were to also have setup, it would look like this. This test shouldn't have a setup, but I just want to be clear about what I'm trying to show you here. I believe that I should be able to define a sketch with nothing more than this. We instantiate a sketch with a setup callback and a draw callback. Now this S, let me explain why this is here. Truly, in an ideal world, it would look like this. If we just call background, where does background come from? Remember that in this concept, these two things are just functions. They're two functions that we're passing in, two callbacks essentially. Kind of like when you pass in an onPressed callback to a button. They're just functions. They don't belong to any particular class. They don't know about any other functionality. Therefore, within a function, or an anonymous function, it has no idea what background is. There is a way that we could allow for this kind of invocation. We would have to make background a static method. Technically, that's possible. Let's go down that road a little bit. If background is a static method, if all of the processing calls are static methods, look at all the static methods we're going to have. Look at all this stuff. There is not a chance in hell that I'm going to pollute the global namespace with all this stuff. So even though that's a technical possibility, I'm not interested in static methods at all. If it's not a static method, I have not been able to think of any other way to accomplish this. I don't know any other way to give these functions access to those calls other than to have the sketch pass itself in like this. This works. But that's also still a bit verbose. Given how many invocations we're going to have in a setup call and a draw call, instead of sketch, I'd rather just call this S. I'm not usually a fan at all of single letter variable names. You'll almost never see me do that except for maybe in for loops for the index variable. The reason that I'm okay with it here is because in a perfect world, it wouldn't exist at all. There wouldn't be any name spacing at all. But technically, to make this work, we do need an object to have those methods defined upon it. And so if you are someone who knows about processing, this shouldn't confuse you. It's going to be s dot everything. So there's only one variable or one, variable or property parameter that you need to be aware of. And so it shouldn't be confusing. Generally, I don't use single variable names. Here, I'm okay with that. Also, once this is implemented so that the references resolve correctly, I also wouldn't include sketch there. Once again, normally I would specify the type because I want other people who are reading my code to know what the parameters are to all these different anonymous functions. I don't like it when people do this and they don't give it the type, because when you start looking at a bunch of callbacks in code, it is not often obvious what those things are. Sometimes you'll have a function that looks like this or something, right? I don't know what those things are. That's a pain that you have to start jumping around into other source files to understand the code. But again, because of the particular situation we're dealing with here, I think S, a singular parameter named S, is reasonable. I think anybody reading this code is going to figure out what that's for. For me right now, and I haven't thought this through very deeply, but as far as I have thought it through, this is the approach that I think makes sense. We can define one or both of the setup and draw functions in line within the widget tree, which removes all of those independent class definitions. Now, one other difference we might want to make is that maybe we don't want this to be the generic sketch constructor, because this is a very, if we implement this, these two provided anonymous functions are going to override the actual setup and draw, or they're going to take the place of the actual setup and draw implementation. So we probably don't want the regular sketch constructor to be used for this. Right now, for the lack of a better term, I'm thinking sketch.simple, because this is kind of the simplest sketch you can define, one that's based only on functions. Simple is also not a good name, because what's simple and what's complicated, and is everything going to be either simple or complicated? All fair criticisms. I think I'm going to go with this for now, but I'm going to reserve the right to refactor this name later. So if you use this package, don't depend on this yet. I may very well change this constructor name to something else that makes more sense. For now, I'm going to go with simple, just so we can move forward. What you see here is the goal. Literally, I want us to go make the changes so that this code compiles and runs. Let's go make that happen. Let's come over here to core. Here's our definition of sketch. I don't know if abstract classes have rules about constructors. I guess we will find out. What we would like to do is say sketch.simple and then take in this. I was going to say this dot draw, but actually we have a public method called draw, so I don't think that's going to fly. we will take in, and then there's the question of the type of it. I will define a type def for this in a moment, but we want to take in a function that accepts a sketch, and we'll call that setup. Then we will call draw. Then we want private versions of those. Then we want to assign the incoming functions to the private versions. The reason they're private is because nobody outside of this class should be touching these things. And then we're going to do this. We're going to come down here into setup, and we're going to say, if setup exists, call it. Why do we pass in this? Actually, let me just I don't want to confuse that. This line will be confusing for those of you who aren't familiar with this syntax. Setup is a function, right? Underscore setup, like that. We can call it like that, but setup expects an argument of type sketch. Therefore, we pass in this. We invoke setup, passing ourselves the sketch object into the setup function. The remaining problem is that setup might be null. Maybe nobody provided a setup function, in which case we could say this right here. There's nothing wrong with that. This code is totally fine. But the if statement plus the setup call is exactly equivalent to this line down here. Same thing. I'm going to reduce it to one line. Once again, I'm doing a number of things here that I have to point out are not always great. I am not someone who always strives for the minimum amount of code. I think that's a total fool's errand. Sometimes it makes sense to write code that is a bit less verbose. Sometimes there are very good readability reasons to be a bit more verbose. As soon as you're comfortable with using the question mark, I don't know if it's considered an operator or what, but when you're used to using that and you're used to invoking functions with call, this line is going to look totally vanilla to you. So that in this case, I think it's okay because anyone who's familiar with Dart, who uses it on a regular basis, will understand this line without issue. Down here in draw, we're going to say draw.call this. Same exact thing. Both of these might be null, both of them might be provided, or maybe just one or the other. We support all of those variations at this point, which means this to-do is done. Find a way to allow for sketch implementations to avoid subclassing sketch. We just did that. Let's save. Let's go back to core test. Let's see, abstract classes cannot be instantiated. So we can define a constructor, but the constructor is useless as long as it's abstract. We will remove the abstract. Now, either clients have to use the simple constructor or they have to subclass. And when they subclass, they will choose to override one or both of these methods. Let's save. Notice that there are no longer any compilation issues here. Now remember, the original test just had the draw function. Can paint background in, oh sorry, this one was just setup. And this should be gray, not orange. I copied the wrong color. Now, apparently I have created some problems down here. Let's see what's going on. The superclass sketch doesn't have a zero argument constructor. Either we can force every subclass to offer its own constructor, or once again, in the interest of simplicity, I think I would prefer that we just offer, I guess const isn't going to work, but let's offer a zero argument constructor right here, because based on our current implementation, there's nothing wrong with that. It's okay for both of these to be null, and they will be null when this constructor runs. Let's save that. come back here to the test, all of those errors go away. So 3 of these tests are still implemented using subclasses, but one of them should be gone. I think this one here. Let's comment you out. Yeah. This is this class right here, paint background in setup sketch. We have replaced that class with an inline implementation based on the rework, the refactoring that we just did. Now comes the first meaningful use of our tests. Well, we already used our test to make sure that our initial API, our initial implementation, produced something, produced what we expected. Now we've made a change, so we expect the exact same thing to be produced, just in a different way. Now we're going to run our tests as tests. We are going to compare goldens instead of generate them. Flutter test core test. Let's see what happens. All tests passed. Now 3 of the tests didn't even change, so that's expected. But this first test right here, we changed the way that we were using the API. We implemented a different way to actually paint the screen. And what we found is that the file that we generate is identical to the previous file, meaning we have successfully changed the API without impacting the functional implementation. It still does what it's supposed to do. Let's go ahead and carry this to the other tests, because I don't think we want any subclasses. This test here is almost identical, except it runs in the draw function instead of setup. Let's save that. Let's run the tests again. By the way, every time you make a change, run your tests. Make a change, run your tests. They still pass, we're still good. Here, the user can paint orange background. Now I need to go copy the orange color again. Here's the orange color. Paste it in there, save, run the tests. All right, all tests pass. And then the last test, it's right down here. This one, oops, pasted too high up. This test uses both the setup and the draw. In setup, we want to paint red, and then in draw, we want to paint gray, which I need to copy again. And with that test migrated, we should be able to delete all of those subclasses. Let's save, run the test again. And they still pass. We've now, this is how you migrate code in a safe way. You make changes, you make sure you have tests before you make changes, and you run your tests again after you make changes. Now, while we're in somewhat of code simplifying mode, each of our tests have this same configuration that sets up a 100 by 100 canvas. Unfortunately, because it is the tester that is configured, this does have to be rerun on every test case to be sure that it's honored. But there's no reason to replicate the exact configuration of the window. I'm going to put this in one global function that's available in the test package or in the test directory, and then I'm going to invoke it from everywhere. I'm going to come to this test directory. I'm going to create a new file. It's going to be called test infra, which stands for infrastructure. This is where I'm going to begin accumulating testing tools that make sense for all or most tests. This one will be, let's say, configure, what's a good name for this? Configure window for spec test. When I say spec, spec as in specification, as in something taken from the processing specification. Because as you open up all of these different documents, I guess size doesn't have one, but most of these things in here have some kind of 100 by 100 example. So these, we will eventually replicate all of these renderings, these 100 by 100 renderings in screenshot tests. These are what I'm referring to when I say a spec test or a specification test. This global function is going to take in a widget tester. I'm going to come back over here. I'm going to copy this code. Going to paste it here. Going to import Flutter test. Going to import, I don't know, rendering. I'm not sure where that's really defined. Save that. I'm going to come back to the test and I'm going to say configure, configure window for spec test. Going to replace all of these configurations. By the way, if any of you in the comments know how I can do this, I would say one time. Really, I need to be able to do it for maybe a group or a group of groups. I don't want to necessarily do it for absolutely every test, but I would like to be able to do it one time for a group of tests. And I haven't found a way to do that because here's where the tester comes from. You don't get a tester in a group. You only get a widget tester per test. So I haven't figured out a better way to do that. For now, I'm just going to simplify it into one call. I'm going to call that at the beginning of every test. Now this too is it's not a source code change, but it is a code change. So we need to make sure that the tests still pass, that we're generating the same screenshots. And they all pass. Great. Once again, here is what we're now looking at for a processing widget with a sketch. Now you may notice that it's still possible to subclass sketch, and that's on purpose and that's important. Sometimes a simple constructor makes perfect sense, but what happens if you actually need local variables? There's no place to store local variables if you're just providing callbacks. In those cases, you will still need to subclass sketch so that you can declare local variables and change them over time. Maybe we'll find some other approach to get around that as well. But for now, if that's what you want to do, if you want to use local variables, you still need to subclass. But for all of the simple stuff, and nearly every test that we do is going to be very simple, this is all we need to invoke right here. The simple constructor, pass in 1 to 2 callbacks, and we're good to go. So this is yet another step on the road to porting processing. I'm going to put up a pull request for this API adjustment, merge it in to the main branch, and then we'll come back in the next video and pick up whatever makes sense for the next task.